This is my Physics 2211 Lab 1 constant velocity. So the purpose of this lab was to compare the positions between an experimental model and a simulated predicted model, which is at constant velocity. We can use physics principles like Newton's second law to construct the computational model. Just to recap on our physics laws, Newton's first law states that an object in motion will stay in motion at constant speed unless acted by an external force. Newton's second law states that the velocity will stay the same if there is no net force on the system. With this, we can derive the velocity update formula by first looking at Newton's second law and just dividing it by mass, which gives us the final output, which is that the final velocity is equal to the initial velocity plus F net divided by m times delta t. So the procedures for this lab follows this format. First, we will let the system be the trolley from our physics lab, and with that, we can record a video of the trolley in motion moving at constant speed. With this video, we can then put it to the tracker application to measure the position of the trolley at each time interval. And once we have this tracked, we can use that data and make a glow script application to create a computational model using the data that we just found. And then lastly, we can compare both the experimental model and the predicted and the simulation that will predict the trolley, and we can make both position versus time graphs for those. So here is a video of our trolley. So in our physics lab, we recorded a trolley moving vertically with the tools given to us. And this video was recorded as soon as the object lost contact from our hand. So based upon this video, we can insert it into the tracking simulation, the tracker app, and get its initial velocity, which we got as negative 0.00622 meters. And this is also in the y direction. And using a very small displacement divided by a very small time interval, we can get that the initial velocity was negative 0.36479 meters per second. And with this, we can now create a computational model. So in GlowScript, we can put in what we just found. So since we know that initial velocity is equal to final velocity, because F net is 0 due to constant velocity, we know that the initial velocity is negative 0.36479. So we can input that in our GlowScript application here. And since we recorded the video at 30 frames per second, this gives that delta t is equal to 0.033, which is just 1 divided by 30. And since mass does not affect velocity due to constant speed, we can just set the max or the mass to just some arbitrary number. And below here, we just put the position update formula, which is the position plus the velocity times delta t. And we know that the velocity will not change due to F net being 0. So when we actually run this simulation, we can get data that we can put into a position versus time graph. So here is a chart that has both the experimental model, which is the video that was just shown, and we can also see the simulated predicted model. And we can see that there's this little difference here. So there are some explanations for this. First, there could have been some external force on the object in the video. So maybe like a hand was maybe like pushing it, or maybe some friction forces such as air friction. Some other explanations for this could be that there were some tracking precision issues when getting the actual data. So what if we flip the axis? If we flip the axis, then the graph would still look very familiar. However, the slope would actually change. So it would go from negative to positive in our case. And is it possible to determine what forces are being asserted if Fnet is equal to 0? Well, based on our observation, we saw that Fnet is not 0. There are many probably external forces on it, and even if Fnet was 0, it would be very difficult to figure out all the forces on that object.